So hello everyone. Today in this video we will be talking with about Tower of Hanoi, right? So in this video we will be first talking about the story which is related to Tower of Hanoi. Then we will jump into the code and we will try to get the logic. Many of you have seen in the video of in YouTube video or somewhere that this Tower of Hanoi problem is said to be very easy but very complex to understand, right? So I will be giving you very easy code and with very easy logic with the help of assumptions, and you can never forget this approach that I am going to discuss in today's video. So let's start. First we will talk about the story behind it, right? So there are lots of story related to Tower of Hanoi, and why it is called Tower of Hanoi, and this Tower of Hanoi is also called Tower of Brahma. So there is a great very famous Hindu story related to this. In Rig Veda, actually, it is written that who have created this world, who have created the universe, Brahma, right? So Brahma has created the universe, and he's also called like a creator of the universe, right? So Brahma has created the universe, and when at the time when he was creating universe, it was said that there is some certain this universe is for certain period of time, and that period of time is actually related to Tower of Hanoi. I will be discussing about the age of universe, right? So it is believed that Brahma has given three towers, right? Three towers, and actually, this is called Tower of Hanoi because of this city, which is famous called as Hanoi, right? And it is believed that this story started with this, but many of the Hindus religion believe that this story actually uh, lie in the Kashi, right? Kashi temple. It is said that we have actually three rods in this somewhere in the Kasi, that all and it is there are three rod, and we need to pass all the rods to destination, right? I'm just giving you one example, but talking about the story, Brahma has given 64 disk. Brahma has given 64 disk, and he actually, this 64 disk is not a normal disk. This 64 is very golden disk, and which is very very big, right? And it is believed that somewhere in the Kashi, still people move one disk in one day, right? One disk in one day. And there are some rules which is also called Brahma rule. In this rule, what we need to do, I'm just giving you one very simple example with three disks only, right? I'm not talking about the 64 disk. Let's understand this example with the help of this example, with the help of three disk only, right? So I am taking n is equal to 3. Now what is the rule? Rule number one is we need to transfer all the pieces from this source to destination, right? We need to move all this disk from source to destination, and order should be maintained, right? It means if this orange is in first place and blue is in the second and the red in the third, the same thing should be here, right? I will be showing you very shortly. So we actually we need to do this with the help of this helper, right? Now are you thinking how we can do it very easily, right? But there are a few more rules, like we can move only one disk at a time, right? We can transfer only one disk at one time, right? And it is the third rule which makes it very complex, and that is a disk can be placed either on an empty rod or on the top of a disk that the bigger that's bigger than itself. It means we cannot place this red on this orange part, right? Because orange disk is smaller and red one is bigger, right? So we need to maintain this all the three rules. We need to follow all the three rules. That is also called Brahma rule. Now talking about the logic, if I'm just giving you a brief idea, and it will be very helpful for us to solve question, right? So first I am just giving you very a small idea. Let's say, if what if we have only one disk? Suppose we have the same tower, right? Same rod, there are three rods, right? So suppose what if we need to move this source to destination, we need to move only one disk from source to destination with the help of this helper, rod, right? So what you need to do, you don't even need this helper. What you are going to do, you are just going to shift this disk from source to destination directly, right? So if you have only one disk, one disk, then you just need one move to shift this disk from source to destination. Let's suppose you have two disks, right? You have two disks. Now we need to maintain the order, right? So what you need to do, you need to move this you need to move this disk first in the helper, right? First you need to move it to helper, then you can move this disk now, the bottom one disk, right, the bigger disk, to destination. So what how many moves we did till now? First we moved this smaller disk to helper. So first we moved this smaller disk to helper, and then we move this larger disk, that is the last disk of this source, to destination, right? So source to destination, and again we are going to put this smaller disk over back to this destination. It means helper to destination. So we can see for n is equal to 2, for actually two disk, we are doing three moves, right? We are doing three moves. Similarly, for n is equal to 3, we are going to 7 moves. N is equal to 4, we are going to do 15 moves. N is equal to 5, we are going to 31 moves, and for 6 we are going to 63 moves, and so on. Similarly, we can get actually one formula. If we have n disk, we have, if someone is giving me n disk, then how many steps we need to follow? We need to follow 2 to the power n minus 1. You can see this is actually 2 to the power 0, that is n minus 1, right? That is n minus 1, that is 2 to the power 1 minus 1, that is 2 to the power 0, that is only 1, right? So this is one move. If someone is giving you n is equal to 2 to 2 to the power n minus 2, n minus, right, n minus 1, so again it will be 2 to the power 2 minus 1, that is two moves, sorry, yeah, uh 2 to the power n minus 1, right? So n minus 1 is said, it is actually, mm, yeah, yeah, good. Not it is not in the power, right? It is not in the power. 2 to the power n minus 1, this is like this, right? So minus 1. So 2 minus 1, that is 1. Similarly, 2 to the power n, that is 2 to the power 2 is what, 4. 4 minus 1, that is 3 disk. Similarly, 2 to the power 3 is 8 minus 1, that is 7 moves. Similarly, so on, right? So we got this formula, that is 2 to the power n minus 1, right? This is the formula. If someone is giving me n disk and asking us to how many steps, in how many steps you can move this number of disk from source to destination, then we can simply use this formula, right? So let's see. So talking about the golden disc, let's come into our story. That Brahma has given 64 golden discs, and it is believed that one golden disc is very heavy, right? One golden disc is very heavy. So if you need to move it from one rod to another rod, then you need at least 1 day time, right? It takes 1 day time to move one golden disc from one rod to another rod, right? It means, talking about the formula that we have just seen, right? 2 to the power n minus 1. It means we have the formula of 2 to the power 64, 2 to the power 64 minus 1. So this is the time that we are going to take. We are going to take to move 64 golden disk from source to destination with the help of an extra rod, that is helper rod, right? So talking about when universe will come to end, yeah, universe is going to end. It is believed universe, if we are going to calculate this to the power 64 minus 1 now, we are going to get this number. And since we are just expecting that we can move one disk in one time only, right? And we can move one disk in 1 day only. So according to this rule, we are going to take 585 billion years to complete this task. So don't worry, we have enough time, right? We can take lots of new birth, right? Let's move to the logic part now. So this was all about the story, it is believed, right? Actually, I have also given the presentation in my college days for this. So let's come to the logic part now. Now talking about the logic, and we will again write the code for this. Let's say I am just giving you one example, n is equal to 2. Since we have seen n is equal to 1, I am giving you n is equal to 1 example. So what I told you, that if we want to move this two disk from source to destination, what we need to do, we need to move this green disk to the helper part. Then what we need to do, we need to move this larger disk to the destination path, right? And what you again need to do, you need to move the smaller disk to the destination. So what are the steps we just followed, right? Let's revise the steps first, right? First, what we did, we moved we moved this disk, that is upper part of the disk. We are on the last disk, right? We are starting from the last disk, and we just passed this disk to helper, right? So we just passed this disk to helper. After that, we taken our larger disk and we moved it to destination, right? The first step was move from source to helper, right? Move disk 1 from source to helper. Similarly, move disk 2, that is disk 2, and disk 1, this is disk 1, this is disk 2, right? So we have moved disk 1 from source to helper. We need to move disk 2 from source to destination, and similarly we can move disk 1 again from helper to destination. Okay, so we can follow these three steps and we can move our given two disks from source to destination very easily. So this was very easy part, right? For n is equal to 2. Just I am taking one more example in which I am just taking n is equal to 3 this time, right? So we need to follow the same rules that a smaller disk we cannot put a larger disk over a smaller disk, and we can move only one disk at a time, right? And the order should be maintained. Okay, we need to follow all the rules that I discussed. Okay, how we are going to do this? Yeah, we are going to do this very simply, right? Again, what we are going to do, we are going to move this n minus let's say n minus 2 disk, right? This is n minus 2 disk. We need to move it to helper, right? We need to move it to helper. We need to move it, this is source, this is helper, and this is destination. What we need to do, we need to move it to helper. So we will move it to helper. Now you are thinking, are you thinking that how I am moving two disk at a time? No, I'm not moving two disk at a time. I'm just assuming that recursion is going to do our task for us, right? So how I am assuming, let's say ki, let's forget about this last disk, right? If we had only two disks, and if I am asking you to move this two disk from source to destination, right? Now this will be our new destination, because we want to move this two disk. This is only the logic part, right? This is only logic. If you will understand this, now you are going to solve this question very easily and you are not going to forget it. What we need to do, we need to move n minus 1 disk from source to helper, right? So for that we need to pass it to recursion, but recursion don't know how to move this source to helper, right? So we need to tell recursion that recursion, don't worry about the bigger problem, just worry about the smaller problem. I am giving you two disks and I am asking you to move this two disk from source to helper with the help of destination. Don't get confused. This time I am giving this is for us, right? This is for us, that is source, helper, and destination. But for recursion don't know which is source, which is helper, which is destination. Since we are starting from here, so recursion will get to know, yeah, this is source, but recursion don't know which is destination and which is helper rod, right? So we are going to use this information, we are going to take advantage of this condition, and we are asking recursion to move I am now asking recursion to move this two disk from source to helper. But this is helper for us, but for recursion this is actually destination. So recursion is thinking that we need to move this two disk from source to destination. Now recursion will ask me ki, do you have any extra rod so that I can take help from that rod? So we will give this extra rod, we will say, yeah, this is your extra rod, but this is actually destination for us. But don't worry about it. Now we can assume that recursion will move this two disk from source to helper with the help of destination. So recursion will do our task for us. So that's why I am assuming that recursion have already did its work. And now what we need to do, again, what you need to do, you need to move our bigger disk, that is which is present on the source, to destination. So that's what I am going to do, that's it. Now again we need to call recursion and we need to ask recursion that, hey recursion, please move move this two disk from this source. Now think this as your source. Now think this rod as your source and move it to destination. Now this will be your destination. Now recursion will again ask me that, do you have some extra rod? I want some help, right? So we will give this time, we will give this source rod as extra rod. So we will pass this source rod as extra rod to helper rod, right? So we are going to pass this rod to recursion, and we are going to ask recursion, please move from this source to destination. Now recursion is going to do our task for us. Now recursion will move this two disk from helper to destination with the help of source. That's it, right? So we again moved this three disk from source to destination, है ना? So we did our work. Now the same thing we need to do, the same thing we need to do in our uh, program. What we need to do, let me write the program first, right? So let's come to this question. Now we have the tower of Hanoi, the same thing and the same rules that I followed, right, that I just discussed. The same rule we need to say. And what I am saying now, we need to move from source to destination. Now what I am doing, first we need to write the base case, right? So let's write the base case. What will be our base case? What if I have already told you in the last two videos of recursion that think base case as think base case as the minimum possible value, and we know the minimum possible value for this will be what, if disk is equal to 0. In that case we are not going to call any recursion, or we are not going to do anything. We are just going to return that if you have 0 disk, then no need to do anything else, right? Okay. Now what we need to do, we need to first, what we have decided, if we have three disk, what we have decided, we are going to call recursion, right? So we are going to call recursion. So I am going to copy the same function, but we have decided, I am just following the same thing, right? Now we are going to call recursion, and what we have decided, we will pass, how many disks? We will pass disk minus one. It means if we have three disks, then we are going to pass the other two disks, right? And what we are going to say to recursion, we are going to ask recursion, hey recursion, please move this n minus, that is disk minus one disk, from source to helper with the help of destination, right? Hana? That's what we are going to do. Source will be very same, but now this time our destination will be same. Destination will be what? Destination will be what? Destination will be actually helper rod. But recursion don't know this, right? We, according to us, this is actually a helper, or you can say auxiliary. I am just changing the variable name so you don't get confused. What we need to do now, we need to move from source to helper, right? So we are just doing the same thing. We are trying to move from source to helper, but recursion need one extra rod to do this task, right? So we are passing as an extra rod, we are passing destination. We are passing destination, right? So the same thing we are doing. So what we did here, let me explain you again. What we did here, we actually pass source, right? And let's look the parameter, right? We need what? First we need to pass the, first we need to pass source, then helper, then destination. So this will be your destination, this will be your source, and this will be your middle part will be your helper, right? But in recursion part, we are passing that this is your source and this is your destination, and this destination is what, actually helper, and with the help of destination rod, okay? So just I am going to do the same task what I have told you, and after that we need to just do what, let me go through this ppt again, right? Let me go through this ppt again. So just I'm going in the last slide, and I will show you the same thing again. Like we have n is equal to 3. What we decided, we will move this n minus 1 disk, we will move this n minus 1 disk, this n minus 1, that is this 2 disk, right? N minus 1, that is 2. We need to call recursion, and we are assuming that recursion will do our task, and recursion will move from this source to destination in the sense, this is a destination for recursion, but we know this is actually helper rod, right? But we have just passed recursion that you need to move this two rod, right? And recursion asks me, where is your destination? We are passing this helper is your destination. And recursion need one more thing, that is helper. So we are going to pass this destination rod to recursion, that you are going to use this rod as your helper. So recursion have done our task for us. Now what we need to do, we need to move this part, this last disk, from source to destination. Now this will be your real source to destination, right? After that you are just going to print this step, and after that what you need to do, again move from this helper. So from this helper, this will be your source. Now move from this to destination. The destination will be same, but now source will be helper, and this this source will be act as helper, right? because we need another empty rod so that we can perform this action. Recursion can perform this action actually. So we are just going to do the same thing. And after we are calling recursion, after we our task, recursion will again do its task, and recursion will move all the disk to destination part. Okay, so let's come to the code again. And what I have done the first step, right? I have just written that we are assuming now recursion have done its task, and recursion and moved n minus 1 disk from source to destination, that is to helper, with the help of destination route that we did, right? Now what we need to do, we need to just print the lines, right? System dot out dot print. Let's write system dot out dot print. And what I'm trying to do, I'm just printing source to destination, because this will be your last rod, right? So we are just moving that rod, right? Moving that disk है ना, from source to destination. That is the same thing we are doing. We are just passing destination, right? We are just passing destination. After that, what we are doing again, we are going to call recursion. Again we are going to call recursion, and again we need to move that n minus 1 disk, which is where. So now it is in the helper part, right? Now we need to move from helper, right? We need to move it from helper. So now this will be your source, right? Because the format is what, first we need to pass the source, then helper, then destination. Now this time, what will be your source rod? Helper will be your source rod. Now what will be your destination? Your destination will be the destination part only, right? So destination is the same thing. And after that, what will be your helper rod? Helper rod will be actually helper. That is going to be your source, right? That is going to be your source. So with the help of source, you are moving from helper rod, you are moving all the n minus 1 disk from helper to destination, right? So now I am submitting the solution once, and let's see if it is working. Let's see if it is working, right? So so this is how we can solve this question, right? I hope now it is clear for everyone. And now I hope you can even write the code for this. Thank you. If you like the video, please like and subscribe.